You're watching the Weiss channel. Today we're talking about whether it's a function or not. Okay? For example, now this is incredibly easy. All right? It's just, is it a function or not? And all you have to know is, do the x values repeat? If the x values repeat, it's not a function. If they don't repeat, it is. For example, do you see how x here is 1, 3, 5, and 7? There's no repeating of the x values. That's a function. Look over here. Here, you see how you have 1, 3, 3, and 7? The 3's repeat. The x values repeat. That's not a function. That's all this is. Function or not a function. Okay? Over here, it's a function. -5, -2, 0, 3, 7, 9. Function. Over here, -7, -3, 0, 2, 4, 7, 9. Function. Look at the y's. 5, 5, 5, 5, 5, 5. The y's repeat. That's okay. That's still a function if the x's do not repeat. The y's can repeat, the x's cannot. Over here, not a function because -5, -2, -2. All right, the x's repeat, not a function. Over here, -2, -2, -2, -2, -2, not a function. Okay. So one way that Delta Math says this, and you have to do this drop-down menu thing, okay? So here, for each value of x, well, let's put it over here for the function. It's a function because for each value of x, there is one value for y, all right? Now, they might say for each value of set A, which are the x values, there is one value for set B, okay? So play with that a bit, and if you get stuck, you're just gonna have to ask me in class, okay? All right, is this a function? Yes, you have -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, and 3. Function. Is this one a function? -2, -2, repeat. No, not a function. Is this a function? Yes, -9, -7, -5, -3, -1, 1, 3, 5, 7, 9, 11, 13. That's a function. Okay. Here, this is a function because for each value in set A, it maps onto one value in set B. This is good. It's 1 to 1, 1 to 1, 1 to 1. All right. Let me show you when it wouldn't work. Look, see how from the 3, there's 2 values. 3 goes to 6 and 3 goes to 7. That's not a function. Okay. This is okay. -8 goes to 5. 1 goes to 5. 7 goes to 5. Each value in x goes to only one value. Okay? You can't have one value go to multiple numbers. You can't have from the input go to multiple values in the output. Okay? So by the way, this would also be called the input and this would be called the output. Okay? This is okay. All right? There's -9 and -4 both go to -1. That's okay. That's a function. 0 going to 2, 3 going to 5. Each x value goes to one y value, okay? But this is not good. See how the -7 goes to 2 values. That's not a function, okay? Is this a function? The 0 goes to 2 values. No. Is this a function? Yes, okay? Is this a function? No. The 1 goes to 2 values. No good. Okay. Then there's this. Here, we're going to use what's called the vertical line test. Meaning, for example, here, all right, see there's multiple x that like -1 is here and here and here in this graph here. Positive 1 is here, here, and here. Right? Positive 3 is here, here, and here. That's not good. Right? You can only have one value for x if it's a function. So this fails what's called the vertical line test. If a straight up and down line, a vertical line goes through more than 1 point, it is not a function. This is a function. A vertical line will not go through more than 1 point. This is a function. A vertical line will not go through more than 1 point. This is a function. A vertical line will not go through more than 1 point. Not a function, obviously. This is infinitely many points that goes through. A vertical line goes through. Vertical line goes through 3 points here. Vertical line goes through 2 points here. These are not functions, okay? Is this a function? Yes. Is this a function? No. Is this a function? Yes. Is this a function? No. Is this a function? No. Is this a function? Yes. You've been watching the Weiss channel. Dat.